So we need to first combine these, and can we multiply them together first? Good question. Why?
Because they're the same.
Okay, same root. So I've got a third root on both of them. So that means I just multiply together each part. So 6 and a 4 would give us the third root of 24. X to the third and x squared gives me x to what power? Fifth. And then y to the fourth and y squared gives me y to the sixth. Everybody good with that part? Okay, now the fun stuff. So this was the second, the 6.2. Now going back to 6.1. We have to simplify this. So I'm looking for two numbers that multiply to give me 24 where one's a perfect cube. 8 and 3. Which one's the perfect cube? What's the cube root of 8? Okay, so we're taking the 2 out. We're leaving a 3 in the house because we can't do anything with that. And then I'm going to break this x to the fifth down to x to what power? What power am I breaking it down to now?
The third.
Third, because it's the third root. So I have x to the third, x squared. What's the cube root of x to the third?
X.
Just x. So I bring an x out. My x squared stays in the house. And then here I have y to the third, y to the third. So I have two of those. So this comes out y squared. And that's your answer.
I had
Easy.
y squared right, but I didn't get x squared right. Or x right.
What did you write on the outside?
I had 2x squared y squared. I don't know.
Yeah, only one. Okay, we're going to start the second half of 6.2 today, and we're going to divide, but that's really kind of fake. We're not really, I mean, we're going to divide a little bit, but it's mainly just rationalize the denominator. And let me look at her. Okay, so the first type of problem you'll see is something like this. The square root of 18x to the fifth divided by the square root of 2x to the third. So there's a couple different things that can happen. Sometimes when you have something like this, the square root on the top and the square root on the bottom, that just means the whole thing is being square rooted. 18x to the fifth divided by 2x to the third. Sometimes it's easiest if we look at what's inside the house as a fraction, as can I simplify this down? So 18 divided by 2 is what? 9. So this I'm left with the square root of 9. And then x to the fifth over x to the third gives me x squared. And there's nothing left over on the bottom. So now I just have the square root of 9x squared, which is 3x. So there's times that you can look at these and divide up and down first, and it makes it very easy to simplify the radical. So that's one method. The other one, you did it a lot in geometry, but if I have 1 over the square root of 2, what's wrong with that picture? What do I have in a place that shouldn't be? Anybody remember?
Square root.
Square root on the bottom. So in math land, it's bad to have the square root on the bottom. So we do something called rationalizing the denominator. And I think once you see me do it, you'll be like, oh yeah, we did this all the time in Algebra 2. But to get the square root off of the bottom, I'm going to multiply the top and the bottom by whatever that square root in the denominator is. So I'm going to do the square root of 2 on the top and on the bottom. On the top, I just have 1 times the square root of 2, so it's just the square root of 2. And on the bottom, the square root of 2 times the square root of 2 is the square root of what? I heard it. 4. 2 times 2 is 4. What's the square root of 4? 2. And it's always going to work out, if you multiply the same number underneath the radical by itself, you'll end up with just that number. Okay, which is great because now I don't have the square root on the bottom. It's on the top, and we can have it on the top. We just can't have it on the bottom. Now, here's a tricky question. Think about multiplying what you can multiply together and what you can't. Can I divide these two and simplify them? don't know, I just heard some people say no. Think about multiplying. You can only multiply together the stuff that are in the house with each other and the stuff that's out of the house with each other.
Then no.
So no, because this is in the house, this is out of the house. And now if I would have had something out of the house, then I could simplify it, which we're gonna do in here in a
That's
minute.
your answer?
So this is your answer.
That's not bad.
No. So now let's throw some X's and Y's in there for fun.
Yay.
Actually, no, I still think I'm gonna stick with just numbers for right now. Okay, so let's say I have something like this. The square root of 100 over 5. I'm gonna split it up like what we just did. So I'd have the square root of 100 over the square root of 5. What's the square root of 100? 10. What's the square root of 5?
Oh, we don't know.
We don't know. It's just the square root of 5. So now from here on, I want you guys to rationalize this denominator. Multiply the top and the bottom by the denominator in the bottom. Torrance, you need to put your phone away.
Uh-oh.
So I want to take the square root of 5 and go on the top and on the bottom. I said that backwards. So 10 times the square root of 5. This is out of the house, this is in the house, so I can't do anything with it. I'm just going to write it 10 square root of 5. And what is that over? What does this become down here? Just 5. Now, though, I have a 10 and a 5, both outside the house. 10 divided by 5 is... So I get 2 times the square root of 5.
That's your answer.
That's your answer. The other way you could have done this is 105 divide. They're both under here to be 20. So I have the square root of 20, which that breaks down to 4 and 5. Square root of 4 is 2. And then 5 stays in the house. So you can do it either way. I'm not going to tell you one way to what to do it. It's kind of however your brain thinks. I wanted to show it this way so you could see the rationalizing one more time, but I won't tell you which way to do it. Let's do. Actually, I think I just want you to go over this or start the homework so I can answer questions as you go.
Yeah, everybody's...
And then I do want to go over this in class, though. So we have page 371.
Round with the group. 125.
Damn, that's all time. Oh, wow.
Oh, wait.
Hey, Jared, what number were you?
You're right. You've got lots of time.